keyword? We had a quiz on this last class.
It refers to itself. What I remember.
You remember? That should be ingrained in your soul, though, this keyword. Within an instance of a class, this keyword is how an instance refers to itself. If you were inside the class, this is how we refer to ourselves. Super important. And also related to the super keyword. What's the super keyword? That could be another quiz, right? Did I tell you guys about the extra credit?
Yes.
Okay. So what's the super keyword? So this refers to myself, super refers to my parent. Okay? Correct. And fair warning, it's right after daylight savings. So it's actually you actually lose an hour of sleep. So it'll be as if church starts at 8 and the event thing starts at 9. But officially it starts at 9 and 10. But
You plan that.
no, but my wife will wake me up. Because she's anal about stuff like that.
She doesn't like to be late, I'm sure.
Oh my gosh, no.
Oh, yeah.
I get yelled at. She wants to leave in 5 minutes. I'm still sitting there in my underwear. So I finished my primping in the church bathroom. Totally. We do that during the opening hymn. I am the worst example of well, actually, I'm probably not that bad of an example of a Lutheran, but I'm a pretty bad example of a Christian. I kill zombies on my iPad during church. First-person shooter. Huh? I know. I'm saving them from the apocalypse. I mean, these people don't know how many zombies were killed during that day's service, especially when it goes long. I mean, when somebody's up there taking communion, one of these zombies could run up behind them and, catch them off guard. I'm taking care of that risk.
Yeah.
That's a Christian worldview, I think. Okay, so did we actually write anything with stacks, or we just mentioned stacks? Okay, so let's talk about stacks. So stacks are a special implementation of the linked list data structure. And you want to think about stacks like a stack of magazines or something like that, where the last magazine you put in, you put it on the top of the stack, that's the first one that would come off, because we probably wouldn't grab from the center of a stack, because then the stack becomes unstable, blah, blah, blah. Okay, so in any case, stack typically has 3 functions. We have a function called push, a function called pop, and a function called peek. Okay, so push adds something to the top of the stack. Oh, it looks like I stumbled upon another one of those multi-column dealies here. It's like opening up a pack of magic cards and getting one of those elite guys. Oh. Pop removes the element from the top of the stack. So we push something onto the top of the stack, we pop off the top of the stack. Okay, so it's last in, first out is what a stack is. So if we want to add that, stack is last in, first out, a LIFO. You can call this a last in, first out queue, as opposed to the human version of fairness, where it's first in, first out, right? Get in line first, you're also the first one served. So if you come into a stack, if McDonald's line at lunch was implemented as a stack, and the line's out the door, and you come in and get in the end of the line, you're the next one served. Well, that's how I just kind of stumble up towards the front of the line. I try to act a little off. People just assume I'm the fat special person
Just run into some people.
and just go up right to the front and just start ordering, but kind of have like a slurry speech. That can be another card. Oh my gosh. I'm really bad.
You have to be careful about how you do it, though. Otherwise, they'll just think you're drunk.
Oh, right. You can't act drunk because then people get belligerent. You have to act special. So unethical. Yeah, don't do any of that. Okay, so push adds something to the top of the stack. Pop removes whatever's at the top of the stack off the stack. Peek gets the element at the top of the stack, but does not remove it. So it lets us peek at the top of the stack, look at the top of the stack, but we don't actually remove the element from it. That makes sense? So stacks implement these three methods. So what's push in terms of a linked list? It's add front, correct? What's pop? Remove front. What's peek? I don't remember when we said get at index. Do we actually remove it?
No.
I think we added it.
Peek is, well, display, but
We had one that was just getting the index. Or getting the
Yeah, so here's our get, and this guy returns a node, but it doesn't actually remove the node. Okay, good. So if we're going to implement these, we're going to make a public node, well, public void push. And this guy is going to take in a, we have two versions of these, right? For our current list, we support chars and ints. So we'll have one of these that takes in an int payload. And this guy, well, let's make the generic one first. So I'll have a public void, private void push that takes in a, just call it a payload.
Yeah.
Okay. This guy will take in a payload. We'll call it payload. And we'll say this dot add front our payload. Then we'll have a int payload, and we'll call this dot add front. We'll pass it our int. So actually we don't even need this private method, because we can implement it in terms of our private add front method. So we're going to give them two public interfaces. One public interface that allows them to pass in an int, and what are we going to do? We're going to call the add front method that takes an int. And then we'll have another public interface push that takes in a char. And this guy will just call this dot add front the one that takes in a char. And then the add front method will call its own private add front with the payload. Okay, so that's our implementation of a push.
And linked list, right?
Well, I added it to linked list. We're going to change that here in a second. Okay. Now what's pop? Public node pop. This returns this dot remove front. Okay, so that's pop. Push onto the front, remove from the front. And then peak, public node peak, will return this dot get 0. Oh, this guy throws an exception, so we need to either try and catch the exception, or we'll just do a throws exception in here. If we pass it something that's less than 0 or greater than the length, it'll throw that Amish exception saying blah, 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 bad things have happened, yada, yada, yada. Okay. So, push, pop, and peak. We needed to write 2 versions of push, one for our different types of values that we store in here, but then we implement them in terms of our add front. We only needed to write 1 version of pop. We're just going to return whatever node is at the front of the list. And then peak lets us just see the front of the list, returns as a node, but does not remove it. Make sense? Okay, so the reality is we've implemented all of these inside of a linked list, and we can go and see this thing work. So we'll create a linked list called LL, and this is a new linked list. We'll select LL.push, and let's push an A. LL.push. Let's push a 5. And let's push 2 other things. Push a B, push a 7. Now, if I do an LL.display, what should my list look like? The first element on my stack should be the last thing that I added, correct? So my stack should look like 7B5A. Last thing I added was 7. Thing I added before that was B. Thing I added before that was 5. Thing I added before that was A. So I kept piling them on top of each other. Okay? So there's my 7, B, 5, and A. Make sense? Now, the reality is when we are thinking about working with something as a stack, we probably aren't going to use a linked list and say, well, we know the stack methods are in a linked list. Instead, we're probably going to write our own stack class. Correct? So what I'm going to do here is I'm just going to steal those methods real quick. So exact methods we just wrote, I'm going to use again here in a second. But I'm going to create a new class in here. I'm going to right click. We're going to create a new class. And we're going to make a class called stack. And a stack is going to extends linked list. And then we're going to implement these extra methods inside of here. Okay? Now, we're going to go ahead and give ourselves a constructor for our stack. So we'll say public stack. It's going to take no parameters to build a stack. And does a stack get built in the exact same way as a linked list? Did we change anything in our constructor when we added these methods to a linked list? Nope. So it gets built the same way, right? How do we ask our parent's constructor to do the building? From within stack, within this constructor here, as long as I make it the very first line of my constructor, I can ask my parent's constructor to do the work. Okay? So this is a special syntax for calling upon your parent's constructor. If your parent has more than one constructor, it'll know which one through polymorphism based on what parameters you give it. But in this case, my parent is linked list. Linked list has exactly one constructor here. that takes in no parameters and does the magical set crap up thing. Okay? So inside of stack, when I build a stack, I know that a stack is a linked list because I'm implementing stack in terms of linked list. I say it extends linked list. That means stack gets everything that is inside of linked list. That makes sense? But it's still called a stack. So this lets us kind of think about it in terms of stack. So we'll call it a stack. Constructor just calls our parents constructor. What does push do? Push calls this dot add front. When we look at stack, we don't see an add front, but it's there because we got it from our parent. Now, how do we know it's here? Well, how is it resolved? When I call the push method, it's going to say this dot add front. The first thing it's going to look at is inside of this particular instance of stack, do you see an add front? No. So it's going to walk up the chain. Okay, it's going to walk up to the next level. And who's my next level? Linked list, who's super. Super is my next level. So if it can't find this dot add front, it'll call super dot add front. Okay, and it'll go find add front there. Now, what about when we deal with all these two strings? So remind me again, what does the two-string method do? And who uses it?
Is it change it's used by methods?
Okay, very generic, okay.
Yeah.
There's a very specific method that we use a lot that specifically utilizes the two-string method for objects. What method is that? We use it a lot. Good.
Print.
Huh?
Print.
Println. Yep. So the println method, whenever you pass in an object, it calls that object's two-string method. Okay. Where was two-string initially implemented? In the object class. And the object class's two-string method returns what string?
Memory address.
A memory address looking string, right? Okay, so what do? When we create our own classes, if we want to do something other than the strange memory address looking thing, we write our own two-string method. We override our parents' two-string method, correct? So that when the println method calls two-string on an instance of stack, for example, it will print out whatever stack's two-string method says. It'll look for this dot two-string first. If it doesn't find that, it'll jump to the parent and say, do you have a two-string method? If it doesn't find that, it'll jump to the parent and say, do you have a two-string method? Until it gets all the way to the top and it's looking at object and saying, do you have a two-string method? Yes, you do. Whew. Call the two-string method. If it walks the entire hierarchy and doesn't find your made-up method that you're calling, I don't know, Bob's Bar and Grill method, and passing it a bratwurst or something. If it walks the entire lineage and never finds that method, then you get the error saying method not found, blah, 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 right? Okay, so that's how this is actually working. When we say this dot add front, it will look locally first, especially since we said this dot, okay? Did we need to say this dot here? Could we have just said add front? But then after you guess, explain. So with push, when we implement that, did we have to say this dot add front, or could we have just said add front?
You could have just said add front.
Okay.
Because this keyword is implied.
Okay, true. The keyword is implied. And we're going to keep going down this rabbit hole. Why is it implied? Everything you said is true. So now we're like in double jeopardy. We're like in the cash cab. You have some lifelines.
Because it's the parent.
Call a friend. You can ask Angela.
I might not be right. It's just a caveat right there.
I don't have much more to.
So he said that this keyword is implied, which I completely agree. I'm asking why is it implied? And we may not have specifically talked about this concept. We've danced around it. So I'm adding another piece of information into your brain right now. Why is this keyword implied? Similarly, I'm gonna give you the other side of the coin here. Just for the moment, let me take out these pushes and pops and that stuff. So here's factorial, right, that we wrote last time. We wrote it. We said system.out.println driver.factorial, and I'll pass it a 4. Okay, and this guy will print out 24. Except we wrote the infinite loop. That was our thing for the stack overflow error last class. Pretend it worked for a second. Remember what I'm talking about? The end of class last time, we were showing how you can run out of space on the stack. So we have currently written this guy to here, just there. Now you'll be happy. Now it's 24. Okay. So did I have to say driver.factorial, or could I have just said factorial? I could have just said factorial. Why? Because the driver is implied. The question is why is the driver implied? So we're looking at two separate things here. In this case, is this a class method or an instance method? Class method. How do you know? Static. All right, come back over here to our stack. Is this a class method or instance method? Instance method. How do you know? No static. Okay, so we're looking at one of these. That's an instance method, and I'm asking whether or not we need to say this dot add front, and you're saying no, because this is implied. We have another one that's a class method, and I'm asking, did we need to say driver dot factorial? And you're saying no, because driver is implied. The question is why? Why is driver implied? And similarly, why is this implied? Because up to this point, we've drilled in this concept. How do you call class methods? Using the name of the class in which the method was defined. How do you call instance methods? Using an instance of the class in which the method was defined. And both of those statements are still 100% true. But we're now talking about, well, you didn't actually have to write driver dot here because it is implied. It'll be there whether you write it or not. Just like over here, we didn't actually have to write this dot add front because this dot is implied. It'll be there whether we write it or not. So the question is why is that the case? Well, that's why add front works. Because we didn't write it in here. The parent does have it. But why don't we need to write the this dot part here? Go ahead.
Because isn't it going to search like automatically? Well, I don't want to say automatically, but without this keyword, without us typing it there, it's still going to search for it at the most local level. And then, so for driver, it's going to find it because it's in that driver class, correct?
That's a true statement, but you still need to tell me why.
Why it's going to find it.
Why will it know to search for it locally? We have this concept called context. And this is easiest to explain through an example. If I come back out here to Eclipse and we look at our driver, I'm making these calls from within main, correct? And main is a class method, correct? So anything that happens inside main here is said to be, is happening from a static context. So since it's happening from a static context, everything that you write will be implemented in terms of class members. So I don't actually have to say driver.factorial. I can just say factorial because I am in a static context. So any function I call, any method I call, will be called from the perspective of a class member. Therefore, the driver dot will be added to it because this guy has a static context within the driver class, just like this guy has a static context within the driver class. Similarly, we go back to stack. Why don't I need to say this? we are inside of something that's an instance context, a non-static context, right? Non-static context. So since we're in a non-static context, we have access to everything directly that is not, well, that is an instance method or an instance member. So I can just say add front. And we've seen this work before in our early days of talking about constructors. If I go back to linked list, well, I'm doing it right here. Here's my linked list. I didn't say this dot head or this dot tail. I just said head and tail. And it knew to look at it inside of the instance context, inside of this instance. Where historically I've always done this dot something and this dot something. For some reason I chose to say this dot number of elements, but didn't do that for head and tail. Where we originally saw this is when we took in parameters that had the same name as our fields. And we said, oh, well, we can, so if this guy took in two parameters, an int head and, or let's see, a node head and a node tail, then we would say, if we said head equals head, tail equals tail, we wouldn't know which head and which tail we're talking about. It always resolves to the most local definition. So the way we'd say we're talking about these guys up here is by saying this dot head equals head, which is the most local definition of the variable. Okay, so we've always used this dot all over the place. I'm not saying it's wrong. In fact, I'd still encourage you to do it. But they're not required. Don't need to say it here. Don't need to say it here. Don't need to say it here. Still equivalent to what we had before. It's actually probably a little bit lower performance now, though. The performance is probably worse because now it has to figure out what the context is and then go and call. It'll look locally first for a head and tail. When it doesn't find that, it'll jump up one scope and find it up here. Okay, as opposed to when we said this dot head, this dot tail, this dot number of elements, it knew we were giving it a direct path to exactly where it lives. That make sense? So things that are occurring within a static context automatically have the name of that particular class, the class that we're in for that static context, appended before. Things that are happening within an instance context automatically have this dot appended before, where this dot is an instance of the class you're currently in. Okay, it's because of that context. So if we're back here in stack, push calls upon a method called add front. Whether we say this dot add front or just add front, I actually tend to write this dot add front pretty often. Maybe the main reason I do that, besides it being a better performance, which is probably no reason why I do it. Computer's so fast I don't care much about performance unless I'm writing something that I specifically care about performance. But I say this dot inside of Eclipse, why? One great reason to always say this dot or driver dot. And don't overthink it. I said don't overthink it. Go ahead.
So you just practice so you know what you're doing.
No, that's overthinking it. That's true in the early days. But now we're intermediate programmers, right? We're no longer beginner programmers. We're intermediate programmers. I mean, this guy back here is taking a compiler's class. That's advanced programming. Isn't that thing a nightmare? Oh my God, it's so fun, isn't it? In my defense, I warned him day one. I said, this class is going to be hard. I did, right? Walked right up to him. And he must be trying to graduate early, right? Oh, so you start off, you switch majors?
No. Finally decided one.
Oh, I got you. Well, that's switching majors. I got it. Well, it's good for the Constitution. I mean, the reality is he's no worse than Skippy. So you all know Skippy, don't you? You know Skippy. You know Skippy. You're the only one? Yeah, I love Skippy. What was I talking about? Oh, yeah, Skippy. All right, so no, what was I really? Oh, I asked a question and Abe overthought it. Why do I always put the this keyword in front? Specifically while using Eclipse or tools like Eclipse. Hint, hint.
Because then it shows it shows all the methods available.
Yeah, I get to choose the method I want so I don't mess up the spelling.
Awesome.
Make sense? Similarly, if I'm out here in driver, and I say driver dot, it gives me all the list of things that driver knows about. Why is that? It's because Eclipse knows about context. Make sense? All right, so from this point forward, I don't care if you use this or not, because now we're intermediate programmers and you understand why. But I'd still encourage you to use this and to use the name of the class so you make less spelling errors. You'll code faster. Okay, so questions on that? All right, so now we're back into our stack. So inside stack, when we call push, push is saying let's call this dot add front. And what are we going to do? We are going to look within this context, this non-static context, for a method called add front. When we don't find it, we're going to look up top here. We're going to say, oh, this guy specifically extends linked list. Does he have a method called add front? So we're going to jump to linked list, and we're going to spin through linked list. Now we're in this non-static context, and we're going to come down here. We're going to find add front somewhere. It's in here, right? Man, we've written a lot of code in here, haven't we? Here's our add front. I don't remember if we were coming from the char or the int one. Let's just assume this is the one we were calling. All right, so it'll find it there. Everything's good. Similarly, though, let's say instead of calling it add front, we called it add fronts. Just misspelled it, something like that. Okay, so we said add fronts. Well, it's going to look for add fronts here locally in this non-static context. It's not going to find it. Then it's going to jump to the parent linked list. It's going to look for it here and not find it. Does that mean we're done? Where do we go to next? Good.
Object.
Object. Why? Because there's an invisible extends object up there. So we're going to go to this guy's parent. And this guy's parent is object. We're going to go and look at object. We're going to see, oh, it's not in there. And then it's going to give us an error saying method not found. And we're seeing again that Eclipse knows about contexts. And it says the method add front is undefined for the type stack. Can't find it. Followed the whole lineage, can't find it. What if I say inside here system.out.println this? What's it going to look for locally? We are in a non-static context, correct? So it's going to look for a class, it's going to look for an instance method named what? Named toString. Important concept to ingrain into your soul. What does println do? Whatever, if we pass in an object, which this is an instance of an object, correct? It's specifically an instance of a stack, which is an instance of a linked list, which is an instance of an object. But this guy is an instance of an object. And println specifically calls this guy's toString method. So it's going to look locally for a toString method. Does it find one? Nope. Then we'll go to linked list. Does it find one here? I don't remember if we wrote one or not. Nope. So does that mean we're out of luck? This is an error? Nope. It's going to find the generic toString method inside of object and print out a memory address. So we go out to driver here, and this is in our push for an int payload. We have we'll create a new stack stack S is equal to new stack. And we call the stack constructor, what does it do? It calls upon our parents constructor to set up the head and tail and the number of elements. That's what the parents constructor does. Okay, and again, review. If you want to call your parents constructor, if you want it to do some of the work, you could put other things after this. You can set head back equal to null if you want. I wouldn't recommend that, but you could do it. Actually, you can't do it. Why? Head is private in linked list. Private means we can only access it within the linked list class. If we want to give ourselves access inside the stack class, what would we do? We'd loosen the reins a little bit and make this guy protected, which makes it accessible by us inside the linked list class and our children. Go ahead. A getter. Forgetting it. Well, a getter and a setter. Yeah, a setter to set it to null. Sure. But in this case, we don't have a good reason to do anything with head inside of stack. So we're just going to leave it private. We're not going to do this. But the point I'm making here is you can do additional setup stuff after calling your parents constructor. But what you can't do is you can't do setup stuff before calling your parents constructor. If you're going to utilize your parents constructor for part of the setup, you must call your parents constructor first. It has to be the very first thing you do inside your constructor. Make sense? Okay, so important thing to put away somewhere. Because in this particular case, our parents constructor does everything we want it to do, because a stack really is a linked list. It's just a linked list that we have really minimized the number of things you can do with, right? We said a stack, well, we can't add to the end, because all we can do is push, pop, and peek. That's what a stack is. So a stack is a simplified linked list. Internally, it's implemented as a linked data structure, but it's a very limited linked list. Okay, so if we're going to utilize our parents constructor, you must call it first. Otherwise, the syntax breaks. So if we happen to do int blah up here, and we come in here and say blah is equal to 7, this guy's no longer happy. If you highlight over it, it says constructor call must be the first statement in a constructor. Okay, so you can flip these guys around. Can I drag in here? Aha! Look at that. That never works out that well. No. All right, now it works. I'm accomplishing the same thing, but they make you call upon your parents constructor first, and that way if you're undoing anything your parents constructor did, you're choosing to do that. Make sense? All right, so we'll get rid of our blah. Get rid of our blah. You've already told me that if I create my stack and I push something on there, it'll print out a memory address. S.push, we did on int, so I'll push a 7 onto our stack. Okay, and that's what printed out. Whose memory address is that? Is that the memory address of the node that we just pushed on? Or is it the memory address of the stack itself?
It says stack.
Okay, so I'm going to, after you answer, or after you guess, I'm going to ask you why.
Okay.
So you're saying stack?
I'm saying stack.
Okay, and it's not the correct answer to say because it says stack. You're not wrong. It is stack. Okay? And this actually is reasonable evidence that it's a stack. Because, ever relax. Okay, shake and bake. All right, so yes, it says stack, and that just happens to be how the Java memory management system makes up its addresses. But specifically, this is where we're printing stuff out, and it's printing out this. And what is this an instance of? This is the line of code that did that printing. It's an instance of stack. So we're calling upon stacks toString method, which it couldn't find, so it called link lists toString method, which it couldn't find, so it called objects toString method. And stack is an object. That make sense? Okay. So the reason why this guy is printing out, the reason it's printing out the memory address is because we're printing out this. But the memory address it's printing out is that of the stack, not of the node we just added. And just for Angela's sanity, we'll take this exact line of code, we will put it inside of node.
How is that making me work?
Well, you'll see. You'll see. So we'll put it inside a node, and we'll put it inside the constructor of node. So anytime a node gets built, we'll print out this. And for that particular one, we'll see it says node at blah, blah, blah. So when we say this inside of a node, we're talking about this instance of node. So now we see that we have a node memory address. Oh, we must already have a toString inside of node. We do. Here's our toString here, where we call our parents toString, which is object, and then we call add on to our payload. So here's the node memory address, and here's that it's an int payload, and then here's the stack address. The same exact line of code produced those different outputs, depending on whose context they were in. Make sense?
That makes sense.
All right. So let's come back out here to driver. Let's get rid of this factorial thing. So we have our stack. So we'll push some stuff onto our stack. And there we have the plus, the 8, and the 7. Okay. Now, if I pop stuff off the stack, what will this print out? It's very related to what we spent the last 5 minutes talking about. I'll show you the pop method inside of stack. Here it is in all of its glory. So in the previous screen, the line of code that I wrote, just so you have it all in one place, is s dot, I said system.out.println s dot pop. Okay, that's the line of code we had out there in driver. So I want to know, what will this display if this is what the pop method does? You can give me a generalistic answer in case you don't remember the 3 things we pushed onto the stack.
The last one put on.
Okay, it will be the last one put on it. And how will it display it? What is this guy? What does s.pop boil down to?
Memory address?
What's up?
Memory address?
Here, I'll highlight it. It boils down to a node. Okay? So s.pop will boil down to a node. And if I try to print out a node, an instance of a node, what will print out?
Memory address.
colon.
It'll whatever Node's toString method says to do, right? And Node's toString method, we just looked at it, says print out stupid memory address, which is our parent's toString thing, followed by a colon, followed by whatever my payload is. And what's my payload inside of a node? It's a payload object. So now we got to follow the, we got to jump into the rabbit hole, go into payload. Does payload have a toString? It does not. So it's going to be the memory address of a payload because payload's toString method is not in payload. It's actually in where? Object. It got it from object. All right, so if we run this, we'll see we get the address of a node, the stupid address of a node, followed by a colon, followed by the address, stupid address, of a payload. In this particular case, it was a char payload. Make sense? All right, and this guy is the plus sign. Now, if we wanted to make this even a little slicker, we can go into node, add to our toString, where this guy prints out stupid memory address, followed by a colon, followed by this.payload, which is the stupid memory address of a payload object, followed by a colon, followed by this.payload.get payload, which is a string. That'll give us the actual value that lives in there. So it'll be the plus sign. So I'll run this again, and now we see we get the node, the pointer to the node, followed by a colon, followed by the memory address of our char payload, followed by a colon, followed by the actual value that's in there. Make sense? And that, the pop gave us the thing at the top of the stack. All right, questions about that? Okay. So now, we want to write the code. Got to go back out to, where am I? Driver. Sometimes I get lost on Thursdays. Wednesdays are a very long day for me.
Did the graduate class?
Yep.
Would they bring you this time?
Nothing. None of these guys commute. Every one of these students is local. It's garbage. Because it's only going to hurt their grades. Not even kidding. It's recorded. Tell you, when it's like 6, 7, 8 o'clock at night and you're bringing a fat man a chili dog, that benefits your grade. I don't care how good your ethics are. Seems like every year during finals, you have these students bring in, well, some of you have been in the classes probably, where I've had a student bring in last year they brought in a gluten-free pizza that they baked. It was basically a lasagna.
Wow.
So I was eating that during class while they're taking their test. I've had a cherry pie brought in. Trista, do you guys know Trista? Yeah, Mist. Yeah, Miss does the weird, inappropriate joke. She brings in like beef jerky and stuff like that, like, completely fine, regular things, but she always brings it inside like a Victoria's Secrets bag. So I have to walk off campus through the halls carrying this lingerie bag. Which also only benefits her grade, I guess. What am I talking about?
Victoria's Secret.
Here. So we already printed out the s.pop. Okay, so I added a 7, an 8, and a plus sign. And that gives me a stack that looks like this. Now, what we want to do is we want to do this math. Okay? We want to do this math using a stack. So if we were writing this, our code might have looked like, we might have had a string, 7 plus 8 may have been our string, correct? Okay, now, how would we take that string and load those elements into this stack
In that particular order.
in that particular order. Well, actually, before we do that, let's do the math with the stack in this order. So forget about this for a second. So we're going to write a little function here that will take our stack and do the math. Okay? And for right now, we can assume we only support addition. We'll still have to check to see that it's addition in case they put something that's not supported, but we don't have to go through the whole rigmarole of supporting everything else. We will eventually, but in this case. So we're going to write a little method here. Static int process stack. This guy will take a stack s as a parameter. And we want this guy to go through and actually process the math that's currently on the stack. Make sense? Okay. So how are we going to do that? If we pop off the stack, what's the first thing we find? Go ahead.
Plus sign.
Okay, we'll find the plus sign. Okay, if we found the plus sign, what do we do with it?
Save it.
Okay, how do we know it's an operator? When we pop something off the stack, it's coming off as a node, correct? And nodes hold on to payloads. And we have two types of payloads. We have char payloads and int payloads. Wouldn't all of our operators be char payloads in our little example world here? So we'll do a little loop. For int I is equal to 0, I is less than, actually this is going to be kind of dangerous, while s dot length is greater than 0. As long as we still have crap on our stack. We're going to do it this way rather than the for loop way, because the for loop way, that predisposes that we know how many times we're going to go through it. And if we keep asking the stack how many elements are in you, the stack as we pop things off gets smaller and smaller and smaller. So if we're going to do it the for loop way, we would have had to first do something like size equals s.length. So we have the initial size that doesn't change. Then we can count from 0 to 3. 0, 1, 2 to go through. Okay? But we'll do it with the while loop here. We'll just pretend like we don't know how many elements are in there necessarily. So as long as there's still elements inside of our stack, what are we going to do? Well, we're going to pop the element. So we'll say temp is equal to s dot pop. So we'll pop something off the stack, store it into temp. Now we're interested in whether or not that particular node is holding on to an operator or a number. So we'll say, how do I ask the question? Is this guy holding on to an operator or a number? Remember, temp has a method called get. Actually, does it have a method? Do we have a way of getting a node's payload? We do not. So we'll write a quick little getter called get payload that allows us to get the payload object from a node. So then we're back here. Now I'll say, remember, we can say temp dot get payload to get the payload from it, the payload object. So this guy boils down to a payload object. I want to be able to know whether this node is holding on to a payload that represents a number or a payload that represents an operator. How would I write that code to check that? This could be another good quiz.
You haven't gone to the extra credit thing yet.
Well, this will be the reason why you need the extra credit. You want a hint? You'll need the instance of operator. Talked about that, right? Well, you wouldn't absolutely need the instance of operator. There are other ways you could pull this off, but this is the way I'd like you to solve it, is using the instance of operator. It would be the cleanest way to solve this one. You need the Jeopardy music again? Is that in here? I haven't. I looked it up. I played it for like 10 minutes the other day in some class. Like way after we were done with the quiz, I just kept it playing. The instance of operator is a Boolean operator for determining whether a particular object is an instance of a specific class. How would I know that something is an operator? It would be an instance of what class? The char payload class, right? Okay. So I'm going to ask the question, if temp payload, or temp.get payload, is an instance of char payload, if that's true, that means we have an op. Else, we have a number. Pretty positive we talked about instance of. Might have only been one day. We might not have used it tons, but I'm pretty sure we introduced it. Anybody corroborate that? At least introduced? I have Evan nodded, but I don't really trust much of what he says. All right, so what was I talking about? Oh, here we go. So if this particular payload is an instance of char payload, then we have an op. And as Amish said, we want to store that op somewhere, right? So we'll create a string cur op. And here, we'll set that guy initially to the question mark. That'll let us know that we don't have an operator yet. So if we have an operator, what are we going to do? We're going to store it inside of cur op. We'll say cur op is equal to temp.get payload.get payload. So temp is a node. When we say temp get payload, we get the payload object, which lives in a node. And that payload object has its own payload, which is the string representation of its contents. So this last get payload returns a string. In this case, it would return the string plus sign, the actual payload that's inside of that payload object. Make sense? Okay. Otherwise, we have a number. Well, what number do we have? Well, no, that's what we have up here. If I'm in the else, I either have a 7 or an 8. And I want to do the math. So if I'm down here in this else, I've already read in the plus sign, or potentially haven't read in the plus sign. I'm either looking at the 7 or I'm looking at the 8. If they were loaded in there like this, and I know I'm looking at a number, I know I've already read in the plus sign. If this is the order, this is postfix. Okay, if I'm already looking at the number, I'm sorry, no, this is prefix math. So we're saying plus 8, 7. Okay? So if I've already read in this, and I'm looking at a number, I know I already have my operator. So we know if I say if cur op dot equals we know this will be true, that cur op is not equal to a question mark. If we're in here, we know this if statement will be true. Because we know that we've already replaced this question mark with an actual operator. That make sense? We don't have to write this. I'm just writing the code to explain what we know is true. We know given that we understand the order things are going to be added to our stack. Knowing that the top of the stack is the plus, next thing is the 8, next thing is the 7. Make sense? All right. So what do I do if I'm in here? I want to actually do this math. Well, I'm going to, okay, go ahead.
Get the payload and save it to another variable.
Okay, so I'm going to have another variable up here, probably some sort of running total, right? Maybe we start that guy off at -1. Well, you'll see in a second. -1 means that we don't have something already in there. Okay, so we're going to say if total is currently equal to -1, then we're going to say total gets the value of temp dot get payload, which is a string, and we want the integer dot parse int of that string. So this guy will ultimately boil down to like the string representation of a 7 or the string representation of an 8. And what are we going to do with that? We're going to squeeze it like juice in an orange and get the 7 or the 8 as an integer out of it using this power tool, the parse int power tool from the integer class. Is this a class method or an instance method? Parse int. How do you know?
Because it's called when instance methods are called.
Try again.
Okay.
Class method or instance method? We're seeing a method being called, not defined. When we see a method being defined, we're looking for whether or not the word static is there, right? Now we're seeing it being called. So in order to determine whether or not this guy is an instance method or a class method, we need to do what? We need to look at how it's being called. Who is calling the parse int method? Something called integer, which starts with a capital letter, which means integer is likely a what? A class, which means that parse int is likely a class method. We call class methods using the name of a class. We call instance methods using an instance of a class. So since this guy is likely a class, because it starts with a capital letter, this guy is likely a class method, because we're calling it with a class. Make sense? So this will get us the integer version of this number that's in there. That's if total is equal to -1. If total is not equal to -1, that means we already have a number in there. And if we already have a number in there, then what are we going to do? We're going to say total. Well, here we'll go through the motions of saying if cur op dot equals the plus sign. We only support plus signs right now. So we know this will be true. In our little example here. So if cur op's currently a plus sign, we'll say total is equal to whatever total currently is equal to plus integer.parseInt. Get payload, get payload. The second number. Okay. Then at the very end here, am I returning an int here? Yep. I will come down here and I will return total. Nope. I need to return it outside the loop. There we go. So I'm returning total at the very end. So what's this loop do? It goes through and it keeps popping stuff off our stack until our stack finally has nothing in it. And it does the math in between. So if I come up here and I say system.out.println driver.processStack and I pass it S, this should print out what? 15 if it did the math right. There's our 15. Make sense? For your homework, I'm going to go easy on you. Create a stack class that inherits from linked list and create push, pop, and peek. That's it. Due Tuesday. Okay, so you'll practice with inheritance. You'll practice using your built-in linked list methods for implementing push, pop, and peek. And you've already seen push, pop, and peek are like 1 line long each, right? So potentially you could finish this assignment in like 10 minutes or less.
What's the catch?
No catch. I just want you to practice. We're going to be doing some harder math stuff on Tuesday. And I'm going to be doing it a different way, so I don't want you to practice this way of doing it and then be confused when we talk about it on Tuesday. Besides, this would be good practice, something that feels attainable, but you're probably still going to struggle with the syntax a little bit. Okay? So I'll put that into Angel right now, and I'll see everybody on Tuesday.